Today we're working on and focusing on the types of chemical reactions. It's our first step towards balancing our equations. As you know, our goal is to be able to come up with a product all on our own, knowing only the reactants. So the first one, and I want you following along, watching with this pointer, our first kind is our synthesis. These are our most basic. At its roots, you've got two things, and they come together to create one thing, a combination, a compound, if you will. You could have something along the lines of aluminum and oxygen to create aluminum oxide. This is a lot of what we practiced in the last unit. This should be pretty straightforward. Our decompositions are just the opposite. You can imagine these as something decomposing into two things. So I know that y'all like your cultural references. So you can imagine a synthesis reaction as Drake and Nicki Minaj coming together to create the power couple, Drake and Nicki. A decomposition reaction would be the terrible breakup, which would cause Drake and Nicki, one unit, to turn into Drake and Nicki, two separate things. So decomposition just involves one thing splitting up into two. What we see sometimes with these is even more than two things. You can have three different elements or polyatomic ions. You could have A plus B plus C yield ABC. It doesn't really matter how many there are, so long as it's several things turning into one thing. Our decomposition, same thing. You could have ABC yield A plus B plus C, or yield A plus B, C. The big part of it is that you've got one thing turning into a group, a larger number of smaller things. Then we've got our single replacement. We talked about this one as the Mr. Steal Your Girl. For example, Drake watching as Meek and Nicki dancing together at a club. Drake swoops in, and now Drake and Nicki are together because Drake is more compatible than Meek is. So Meek's here watching from the side pretty jealously because he's less compatible with Nicki than Drake is. Single replacement, it's as simple as one element replacing another to create a new compound and a new side product, because element A in this case is more compatible with element C than element B is. Our double replacement, the big thing about this is you're looking at several compounds. As you're labeling these, you're looking for a ionic bond, an ionic bond here ordinarily. Sometimes you'll see a molecule too, but these are compounds in themselves. Two compounds coming together, and they yield, again, that's this arrow here, needs yield, two separate compounds, two new things. And it's a double switch. It's more like square dancing, if you will. It would be a double date where you've got Nicki and Drake, and Meek and Scarlett Johansson, and they decide to all switch it up and have a little date swap. So, not as jealousy invoking as our single replacement. And then I want you to have to pay attention for are our combustion. These are the ones that light on fire. I'm sure that a lot of you are really interested in a combustion reaction. Hopefully we get a chance to go through a couple examples of these in class. But a combustion takes the basic form, a hydrocarbon, carbon and hydrogen, plus oxygen, which we would see in the form of flames, yielding carbon dioxide and water. To balance these, all we're doing is affecting the coefficients. You can say how many carbon dioxides will form, how many waters, but you're not changing any of these subscripts here. Our combustion, we could see different hydrocarbons. We might see CH4, which we call methane, natural gas. We could see C3H8, what we call propane, or rather octane, plus oxygen, yields some number of carbon dioxides and waters. These are our typical waste products. And we would see these, for example, in a car on a cold day, creating water vapor in the form of steam, which we would see coming out of the exhaust pipe, and the invisible gas carbon dioxide released into the atmosphere as a greenhouse gas, which is something you'll hear a lot about on the news and in various scientific publications. It's a hot topic right now. But all that comes from burning hydrocarbons. Interesting fact for you, as these hydrocarbons, the fuels we use get less pure. For example, a dirty coal versus a clean coal, there are more elements involved in these hydrocarbons, for example, nitrogens and oxygens and other things that burn up as pollutants into the atmosphere. So they come out as a separate waste product on this side, outside of the water and the carbon dioxide, and those are released as pollutants.